So in this chapter, we're going to start talking about motion and forces, and particularly the idea of forces. So previously, we have studied motion and we studied our kinematics equation, but we never worry about the causes of motion. So this is what we're going to be asking now. What causes motion, right? So that's the main question that we want to answer. And for instance, here we have examples of motion. We have a boy on a sled and it is slowing down. So the question is, what causes the boy to slow down, right? Or if you see that if he goes from this smooth snow to ice, then he can go farther, but it's gonna still slow down. And if you take away all the friction, then he'll go forever without slowing down. So the reason he's slowing down here is because of something that we call friction. And friction is a type of force. So the causes of motions, what causes either you to speed up or slow down, are forces. And that's what you're going to be studying in this chapter, forces. So let's start with Newton's first law. Newton's first law says an object that has no forces acting on it, it either will stay at rest, it will never move, or it will continue moving at a constant speed. So if an object is at rest and there's no forces, it's never going to move. If an object is moving with a constant speed v and there's no forces, it is always going to move with that constant speed v. So then we ask ourselves, what is a force? For our purposes in this class, we're going to think of a force as a push or a pull. Okay? So here we have examples of forces. She's exerting a force on this ball. He's exerting a force on the bag. And the quarterback is exerting a force on that ball. So forces, they act on objects. And when they do, they somehow change the motion sometimes if there is a net force. So every force has an agent, something that adds or pulls. So here, the quarterback is the agent, right? He is exerting a force on this ball. Here, the boxer is the agent. He's exerting a force on the bag. So an important property of a force is that it is a vector. So we need two things to specify a force. We need a magnitude and we need a direction. So we typically are going to denote forces with this symbol here, and the magnitude of the force is just going to be the letter. Most forces that we are going to deal with in this course are contact forces. Those are forces that act through pushes, through touch, right? Like friction, normal force. So those are for contact forces. There's also long-range forces, and those act without touching the object. For instance, gravity. Gravity is an important example of a long-range force. How do we draw forces? Well, forces are vectors, so to draw forces, we are going to use the same techniques that we use to draw vectors. We are going to use arrows to specify forces. There's going to be a point where the force is applied. The length of the arrow is going to be proportional to the magnitude of the force, and so basically, to draw a force, you just draw a vector. Here we have examples, right? So she is pulling this box. So the agent is all this, is the rope basically. So there is a force being applied on the box. The object that the force is being applied is this box here. And then we are going to draw a force as a vector, an arrow applied to the box at this point, and it has a length and a direction. Here we have a box that is falling. The agent, of course, is the earth that is pulling. It has a gravitational pull. So the force attached to gravity here The force that we draw is a force acting on this object, and it has a length here. So that's how we draw forces. And forces has a really neat property that makes it possible to deal with them mathematically, and that forces being vectors, you can add them. So if you have a few forces acting on an object, here you have a tension, a force acting on that direction, and a force acting on that direction, then you can talk about the net force. The net force, and the net force is the addition of those two forces like you see here. So this guy here, this vector here, that is the net force.